Okay. Thank you, Jenna, for the baby feed. 1.7, solving by elimination. So we've had a couple of quizzes, we've done the first 6 lessons, and at this point we've kind of been doing the same old over and over and over. We're going to shift a little bit in just how we're going to sort of finish off the rest of the chapter and what we're going to focus on. We're still working with a system of equations, so that means we're still working with 2 rules at the same time. The difference is we're going to look at a different way of solving. So if you remember our last week or even the last couple weeks, we've done solving by graphing 2 lines and seeing where they cross, which is great visually, but it's not very accurate, and most of us have maybe a bit of a problem when we graph because of that accuracy. Then we switched and we looked at solving by comparison, which was technically a grade 9 thing, and that's when we made the 2 y's equal to each other. Some of us got the hang of it, some of us didn't. Most of us understood it, but we made a lot of little silly mistakes, and when I give you back your quizzes later, you'll notice that. You'll notice a lot of small little things. Negatives become positive, 2 plus 2 is 8. Just weird things that our brain does. And we make a lot of small little mistakes. So for the 3rd time, yes, you'll get your quizzes back today. That was part of the 3rd, by the way. So we're going to look at a different way of solving. So we've looked at 2 already, graphing and comparison. We're going to look at a 3rd and last way of solving. And I'll be honest, for the vast majority of people, this will probably be the best way for you guys to move forward. Now, ideally, I would have skipped the other 2 completely and just done solving by elimination just this lesson, and we wouldn't have had any confusion. But we actually do have to know the other 2 for certain types of exam type questions. Okay, so solving by elimination. We can solve a system by elimination if the rules look like this. So when we were doing comparison, and even when we were doing graphing, we would have 2 rules, 2 equations, 2 lines, for example. And for graphing and for comparison, we would say, okay, we can have 2, but both of them would have to be in standard form, y equals, y equals. And the problem with that we sort of realized was that was fine, except when you had to start moving things around, bring the x over or bring the numbers over, divide by 6, that's when the silly mistakes happen. So this elimination method is good in the sense that you don't have to worry about moving things around. Everything stays put on the same side of the equation. You don't have to bring anything over to the left or the right. Everything stays put. You just have to multiply. And it works well when both rules look like this. Capital AX plus capital BY is equal to C. And capital AX plus capital BY is equal to C. Now, it looks more confusing than it is, so just write it down, then we'll talk about it. Now, the capital letters here, the A, the B, and the C, all represent numbers. There could be anything. It could be a 2, could be a 6, could be a 7. It could be really any numbers we want. So these capitals represent numbers. So A, B, C represent numbers. But the bigger thing that we notice here is that both of these rules together makes a system of equations, it creates your group of equations, but neither one of these rules has y equals and y equals. The first one doesn't say y equals, it has this other mess around it. The second one doesn't say y equals, it has another mess around it. And that's actually what we want. We don't want our rules in standard form. So I'll put a little star here saying, neither rule is in standard form. And that's a good thing for us. So we don't have to put it in standard form, which again requires all that extra work and moving things around. We can keep it like this, and we can see how we're going to go from there. Let's do a couple examples here. Solve by elimination. this. Let's do 6x plus 9y is equal to 3, and 2x plus 2y is equal to 9. Hopefully this is one of our last hot days. Cold weather. Okay, so just write it down. Don't worry about anything just yet. We'll make sure we're all on the same page. So we have two rules. First rule here, second rule there. If we were to do this by graphing, we'd have to take each rule, get the y by itself, so that one and that one. We then have two rules. We make two little tables, get dots, connect the dots with lines, and see where they cross. It's a whole lot of work. We're not going to do that. If we did this with the second method, which was comparison, comparison said, okay, take both rules, make sure they're both y equals, so we'd have to do that there first. We have to do that there first, so a little bit of work. And then from there, we can continue. The nice thing about elimination is we don't have to do any of that. Elimination says, okay, if you have this, where you don't have anything in standard form, and they look like sort of this form where they stack on top of each other. You notice how the x's are all lined up, the y's are all lined up. I mean, literally, equal signs are lined up, and the numbers are all lined up. Everything's lined up perfectly. So when it looks like this, elimination works really well. So what we do is we take each one of the rules and just tweak them a little bit, just change them. And how do we change them? Look at the first rule, and then look at the second rule, and find the numbers that are right in front of the x. Clearly there's a 6 there, and there's a 2 there. The 6 and the 2. That's what is going to be our focus. That's really the kick behind here, the shortcut on what we're going to do. I'm going to take the first rule, and I'm just going to draw an arrow here. The arrow just means I'm going to turn it into something else. I'll take the second rule, I'm going to draw an arrow, and the arrow means I'm going to turn it into something else. And the way I'm going to turn it into something else is take my first rule and multiply always that number. So let's take the first rule and multiply it by the number in front of the x of the second rule. That's a 2 there. Let's multiply everything by 2. So let's take our first rule and double everything. 6x times 2 is 12x. 9y times 2 is 18y. Equals 3 times 2 is 6. I'll write in words in a second what I'm doing.
How would you multiply it by 2 if there's a 6?
Yeah, you'll see it. You'll see it in a second. I took my first rule and multiplied it by the number in front of the x of my second rule. And vice versa. Take the second rule, multiply it by the number in front of the x of the first rule. So let's multiply here everything by 6. If I multiply everything by 6 here, I get 2 times 6 is 12x. 2y times 6 is 12y equals 9 times 6 is 54. So I'll write down over here what I'm doing. Multiply each rule by the number in front of the x of the other rule. There are different ways of doing this. I'm showing you one way that will work all the time. If you care about the slight twist, then we can talk about that afterwards. But as a class, I'm showing us one way that will work every single time. The first rule, multiply by that number. The second rule, multiply by that number. Always look for the number in front of the x. Now when you have this, we can go ahead and proceed. The word elimination, it's solving by elimination. Elimination means to get rid of, to cancel, to make it disappear. So what we're going to do is we're going to make one of the variables disappear. Either the x or either the y. this method, and what I'm showing you, will always make the x disappear. So this is what we're going to do. Again, notice how I've written the rules and they're stacked directly on top of each other. I'm going to mash them together. I'll take the first rule and second rule and mash them together by one of two operations. Add them or subtract them. I'm taking the first rule and the second rule, and I'm either going to add them or subtract them. Well, my goal is to eliminate, to get rid of. If I were to add these two rules, I'd get 12x plus 12x is 24x. That did not get rid of the x's. If I took 18y and 12y and add them, I'd get 30y. That would not get rid of the y's. So adding them doesn't help. I can eliminate them by subtracting. So what I'll do is I'll take these two rules and I'll subtract them. Let's do that. 12x minus 12x is nothing. Great, gone, done. 18y minus 12y is 6y. Look at the equal sign, everything's staying lined up. 6 minus 54, you want to have that?
Negative 40.
Negative 48. So I've taken my first rule that I changed, my second rule that I changed, I stacked them and double stacked them on top of each other. And then I decided I'm going to subtract them. And by subtracting them, I actually get rid of one of the variables. Now we have 6y equals negative 48. How can we get the y? Divide by 6. If we divide by 6, let's go ahead and do that. By 6 divided by 6, we get y is equal to negative 48 divided by 6 is negative 8. That's actually pretty quick. That's probably a lot quicker than having to move all the y's around and the x's around and the numbers around from one side to the next. It also saves you that whole headache of, I've got to move it over, do I have to add or subtract it, is it a negative or a positive? You don't have to worry about any of that. You double stack them and just add or subtract them and get rid of everything. Perfect.
Like, you know when times the 2 to the 6?
Yep.
You got that because like the top is 6.
Yeah.
So times the bottom by like the
So I multiplied this one by this number,
yeah.
So it's a cross.
and this one, it's kind of like cross multiplication. I don't want to say the word cross multiplication because that's something very different. But you can imagine it, it's like I'm kind of multiplying this one by this thing across from it, sure. And the 6 here, I'm multiplying the second rule by it. It's always those key first numbers that I focus on. Which you,
Does it change anything if it's not stacked on top of each other? Like if it's not, like let's say it would be 9y plus 6x.
just reversing them. Typically, we don't see that. I'll be honest, in most cases, we see them stacked on top of each other. That's the benefit of this form. Yeah.
The x's.
Yeah, we're not done, by the way, right? Yeah, okay. So we have one of them, but solving means we have to find both of them. We have to find an x and a y. Well, we have the y, we still have to get the x. So this is the one drawback with this method. Everything else so far looks pretty good. We stack them on top of each other just by multiplying, and immediately, very quickly, we get one of the answers. The drawback still is, we still have to put this in to get the other answer. And I'll do that over here because I'm running out of space. Actually, maybe I'll make a little note of what I just did right here. So right there. Either add or subtract the two rules. So we either decide to add or subtract and we'll go from there. Rashima?
I don't think you can see yellow better.
Pardon me?
I don't think you can see the
Thank you. Now we're good? You think?
Now we can't see you over there.
Okay, hold on. Can you see that part at least?
Yeah.
There. If anyone needs to see it, they can see it. Who's supposed to be sitting there? Didn't you guys all shift over?
No.
Jesse, you're my cinematographer, and you left me for the back. We're good? Thank you. Okay, so we're not done. We found the y, let's find the x. Same thing as before. Pick whichever one of these starting rules you think is easier to work with. If you think the first one's easier to work with, use the first one. If you think the second one's easier to work with, use the second one. Makes no difference.
Wait, you
Yeah.
still get the same thing if you subtract it? Or no, you get different?
If I did subtract them, right?
I mean, if you added.
If we add them, quick, we talked about this earlier, but let's add them. 12x plus 12x is 24x. It didn't disappear. We have to eliminate. We have to get rid of it. The only way to get rid of 12x and 12x is if I subtract them. If I add them, I'm going to get a 24x. So we'll do another example in a second. We're not done this one though. Dylan.
So like, let's say it was negative 12x, like what was it? You would just, then you would add.
Actually you still subtract. We'll do another example.
Alright.
Okay, we pick whichever rule you think is the easier one. I'm going to pick the first one. Maybe you think the first one's, or the second one, pardon me. You might think the first rule, the second one's easier, doesn't make a difference. So if I pick the second rule here, I'll take my y that I just found, and just like we were doing before, replace it back in. And I'll write what I'm doing over here. Pick the easier rule and replace y to find x. Okay, so let's do that. My y that I just found was negative 8. So again, 2x plus 2 times negative 8 is equal to 9. And yes, this requires us to do a little bit of work. We've got to move things around. That's okay. Let's calculate. So I have a 2x. 2 times negative 8 is negative 16 equals 9. I'll add 16 to both sides. So if I add 16 here and add 16 here, I get 2x is equal to 25. Divide by 2, and we get x is equal to 12.5. The remaining bit stays the same. Once we find that first x or y, typically we're finding y, put it back in and find your x. So now we have our answer. There's your x, there's your y. So our solution, our answer here is 12.5 for the x and negative 8 for the y. The nice thing about this method is that it's always the same length. You'll never have one question that's longer than the other. It's always the same length. The other nice thing is that when you get that first y, it's fairly quick and it's fairly simple. You really don't have to worry about too many sort of crazy numbers in here. Yeah. I need the space over here, so I'm going to erase this. So if you need that, you can just draw it down quickly. We'll do a second example, and we'll stop there. Okay, so number 2. Got 2x plus 5y is equal to negative 4. 3x minus 2y is equal to 13. If you know what you're doing, go ahead, but I'm going to start this together in just a second. We're going to be using this method, we're going to be using this method likely for the rest of the chapter, so the next 2 weeks. If, at the end of this, you don't like this, you can always go back to comparison. The problem with comparison is that you're going to start getting a lot more ugly numbers and decimals, which is why I'm showing you this method. In this method, you won't get as many. Yeah?
But if it's in standard form,
Yeah, then you could just use comparison, absolutely, for sure.
would this one work with
It
standard
will
form?
always work.
It will work with
Yeah.
standard form?
Yeah. We'll talk more about that either tomorrow or the day after.
Okay.
Okay, so we have 2 rules. If you want to use comparison, you'd have to bring over the 2x and then divide by 5, and you'd have decimals in here. If you wanted to bring over the everything else and get the second rule in standard form, you have to bring over the 3x and divide by 2, you'd have more decimals in there. The nice thing about it is you don't have to worry about decimals. You won't get any decimals at the beginning. Maybe at the end you will, but not at the beginning at all. The way to do this, and also take note of sort of how I'm writing the solution too. When I was looking at your quizzes, some of your solutions are like all over the place. It's really chicken scratch and I can't really figure it out. So take note of how I'm writing this down. I have my question right here. I'm going to draw an arrow off to the side. Do you have to do this? No. But then if you lose marks because your solution isn't neat, don't look at me. I'm suggesting that we do it this way. I'll draw a couple of arrows off to the side. I'll take my first rule and multiply it by the number in front of the x of the second rule, so 3. I'll take my second rule and multiply it by the number in front of the x of the first rule, which is a 2. It will always work like that. Without any doubts, without any question, it will always work this way. Again, that's the nice thing is it will always work no matter what the numbers are. Positive, negative, whatever. So I'll take my first rule and multiply it by 3. I'm going to make a mistake on purpose. So I'm going to make a mistake on purpose so you can see it. And also, I'm saying make a mistake on purpose because this is a common mistake. Okay, so 6x plus 15y is equal to negative.
Negative 4.
What?
You need to times.
Or sorry, I just called you back. Pardon me, Jesse.
You need to times the negative 4.
Yeah, we have to multiply both sides, right? So I multiply this side, but I forgot to multiply this side. So this should be a negative 12 over here. So that's probably the most common mistake, is forgetting to multiply everything there. The second rule is try not to make a mistake here. Let's multiply everything by 2. So when we do that, we get a 6x minus a 4y is equal to 13 times 2 is 26. Now, we have two rules. They're double stacked on top of each other. Everything lines up perfectly. We have to make a decision. Either we're going to add them or subtract them. Now, ideally, you can already look at it and you know which one you're going to do. But worst case scenario, if you're looking at your two rules and you just don't know, should I add or subtract? Just do them both. Try the addition first. If that didn't work, try the subtraction next. One has to work this way. Ideally, though, you know which one you're going to do. Because you look at the x's. If those numbers are the same, which in most cases they're going to be the same, we subtract them.
What about if they're not the same?
Then you haven't done the first step right. That's it. It has to be the same number for this to work out. For us to eliminate this, like those numbers are going to be the same. Jenna? Okay. So multiply the first rule by the second, by the 3, second rule by the 2. Double stack them. We're going to subtract them from here, so let's do that. 6x minus 6x is nothing. Don't write it. You can just leave it alone. Okay.
Like 15 minus, we do 15 minus.
Yeah, so it's 15 minus the negative 4. 15 minus the negative 4, absolutely. Okay?
What happens if the y's end up being the same too?
That won't happen until, well, we're not, yeah. We're months away from that.
Okay.
But we'll get that eventually. So 6x minus 6x disappears. We've got the 15y minus the negative 4. Don't do it in your head. You have a calculator. If you want to do it in your head, fine. But you should get a 19y out of it. Is equal to negative 12 minus the 26. Again, you have a calculator. We can do that. We get negative 38. Okay. So we have that. We can get the y by itself by dividing by 19. So divide by 19. Divide by 19. And we get y as negative 2. If you were to do this using comparison, you'd probably take a lot longer just to get to that number. And with a lot more decimals and everything else. We're not done, but we have at least one of them. So we have the y. So we continue by picking whichever rule you think is easiest to work with. This is your choice. I think I'll pick the first rule. So 2x plus 5y is equal to negative 4. Again, please take note of sort of how my solution looks. That's kind of how I'm writing it. Now, I'm running out of room here, but yours should really just be beside, either right beside it or underneath it. So I'm picking the first rule because I think that might be slightly easier. I'm going to take my y value and put it right back into here where I see my y. So it's a negative 2. Okay. 5 times negative 2 is negative 10. 2x minus 10 is equal to negative 4. We're going to add 10 to both sides. Plus 10, plus 10. I'm really hoping that you can just start doing this in your head and you don't have to write that down. But if you do need to write that down, go ahead. So we get negative 4 plus 10 is 6. Divide both sides by 2. And we get x is 3. And you can see that, again, it takes the same number of steps. It's the same kind of speed every single time. And I finished in the same point as where I finished before. My solution here is 3 for the x and negative 2 for the y. stop it there, but I just want to point out for a couple of you guys,
Can we stop it?
just wait. There might be about 4 or 5 of you that are completely comfortable with your math and you can go a little bit further. If you're not this person, then ignore what I'm going to say. You didn't have to do this. We could have also mashed up the y's and eliminated the y's. So if you find that it's easier for you to do, multiply the first rule by 2 and multiply the second rule by 5. You can do that instead. But that's only for about 4 or 5 of you that are completely comfortable messing around in different ways of what you're doing. But for everyone else, this will work every single time. That's it.